Okay, welcome back. Picking up where we left off yesterday, we are going to find the inverse of this function. And if you remember from yesterday, our first step is to write it in y, replace the f of x with the y. Y equals x squared plus 4x. Step 2 is to exchange the x's and y's. So that becomes x equals y squared plus 4y. You have to replace both x's with a y. Lastly, we have to solve for y. Now, because I have a y squared and a 4y in here, there's no way that I can solve for y by traditional means. But what we can realize is that this is a quadratic function because it has a second power, which means I should use the quadratic formula to solve this. If you remember the quadratic formula, that's negative b plus or minus the square root of b squared minus 4ac all over 2a. So my a is the number in front of the y squared, my b is the 4, and I don't have a c. But we also need this equation set equal to 0 in order to use the quadratic formula. I can't have a number over here and use the quadratic formula, which means I need to subtract my x over to the other side. So this is y squared plus 4y minus x equals 0. So now a is 1, because that's the number in front of y squared. B is 4, and c is negative x. Now I just plug it into the formula. Negative b, that's a negative 4, plus or minus the square root of 4 squared, which is 16, minus 4 times 1 times negative x, all over 2 times a. A is 1, so that's all over 2. Now we start to simplify here. Negative 4 plus or minus square root of 16 plus 4x. Why is it plus? Because I had a negative 4 times 1 times negative x. Negative times a negative becomes a positive. And then that's still over 2. Now under the root here, I have a 16 and a 4. I can factor a 4 out of there. Negative 4 plus or minus the square root of 4 times 4 plus x over 2. And what's the square root of 4? It's going to be a 2. So it's negative 4 plus or minus 2 times the square root of 4 plus x all over 2. Then I can divide both negative 4 and 2 by 2. Don't do anything to the root. I don't have to be able to divide anything in the root by 2. Just the number out in front. And so this is going to simplify. Negative 4 divided by 2 is negative 2. Plus or minus 2 divided by 2 is 1. And it's the square root of 4 plus x. That was fun. I know. I factored a 4 out here because 16 and 4x both have a 4 in them. So I can factor a 4 out. And then if I have a number times another number, then I can take the square root of one of those numbers. I can't take the square root of this 4 plus x because it's adding inside of there. Because there's two things being added together, I can't take that square root, but I can take the square root of the 4. Square root of 4 is 2, so that 2 comes out in front, and then I just simplified this. Negative 4 divided by 2 is negative 2, and 2 divided by 2 is 1. Determining whether an inverse is a function. A function f is 1 to 1 if f of a equals f of b implies that a equals b. In other words, the only way that I can have a function have the same thing equal to itself is if the two numbers that I put into the function are equal. So the outputs can only be equal if I'm putting the same thing in. It's like if I put a loaf of pumpernickel bread into a bread slicer, what comes out? Sliced pumpernickel bread. So if I look on the other bread slicer and I have sliced pumpernickel bread, I know that pumpernickel had to go in. I can't come out with pumpernickel if I put white bread in. Make sense? If I'm making Easy Mac mac and cheese, the only way that I can come out with cooked Easy Mac is if I put a raw Easy Mac in, or an uncooked. I can't put ramen noodles in and come out with an Easy Mac mac and cheese. So that if I come out with Easy Mac, then I know that I had to put that container in there. It had to have been the same thing that I put it. That's all this says. Then once a function is 1 to 1, once we determine that, then that means its inverse is also a function. Whenever I look at this function, well, first, is it a function? If I do a vertical line test, it shows that it is a function because it only crosses each point one time, right? But let's think about the output of this function. If I put a negative 2 in, I get a 4 out, right? Because it's negative 2, 4. By the way, this is y equals x squared. That's this function. If I put a negative 4 in, or a negative 2 in, negative 2 squared is 4. So would this function be 1 to 1? The answer to that is no. It would not be a 1 to 1 function. Because if I put negative 2 into the microwave, I get 4 out. But if I put 2 in, I also get 4. So I put two separate things in, and I came out with the same answer. So this function would not be a 1 to 1 function, because I'm putting 2 in and coming out with the same answer. Questions? So since this function is not 1 to 1, then its inverse is not a function. So if you remember from the first day we started this lesson, on the way back machine, we took that function, we found its inverse by flipping the x's and y's, and now if I try to do the vertical line test on this function, it crosses 2 points. So it fails the vertical line test. So the inverse is not a function. We don't even have to find the inverse to figure out if it's a function. All I need to know is my original 1 to 1. If it's not, then it's not a function. Like and subscribe. function f is 1-to-1 if and only if no horizontal line intersects the graph of f more than once. So the original function, if I look at that, which we're going to go back to, if I look at this original function, if I take my line and make it horizontal, if it crosses the graph at more than one spot as a horizontal line, then my inverse won't be a function. So I don't even need to find the inverse to tell whether it's going to be a function. This crosses here and here, so I know the inverse is not a function because this fails the horizontal line test. I want you to graph these functions. Tell me which ones are 1-to-1. The first one is 1-to-1. The second one is this graph here, which if I draw a horizontal line through it, says it's not 1-to-1. Now the question is with C. This one looks a little tricky because I have a horizontal line intersecting there, right? And so your best bet is going to be to zoom. So you're going to want to graph it and zoom, because even though this line looks horizontal in the center there, it might not be. When I look at this on Desmos, this looks horizontal way back here, right? As I zoom in, it looks less and less horizontal. When I get all the way in, it definitely looks like it's a straight line. But let's drag across it, because you'll notice that this straight line is doing what? What's happening to my y value? Is it? The x goes up, the y stays the same. So since the y is staying the same, it is a horizontal line in the center, and that is a no. It is important to zoom in though, because there are going to be some specific examples where it looks like a horizontal and it's not. Like for instance this one. Because we said it was a horizontal at 1, and now it's changing because it's 1.001 here. And the further I zoom in, this is all staying 1. So it's still fine as a horizontal. But you see how far I would have to zoom in to see on the outside here that it's not actually horizontal. Like as we get to the edges of this. There'll be some examples where it's really close. I generally won't give you those examples on quizzes and stuff, but on homeworks I have no problem giving it to you. It's the homework. But like if I change this number down to like point, well, if I made it go up, I made it 5x cubed. Can you see how little it stays horizontal? It's never horizontal. It comes in much further. Like that. If I made it 500, then it still hits horizontal, but it's for a much smaller amount of time. So it's something to watch out for. I'm not going to be too picky with it, but okay, that is it for today. I'm going to give you some homework problems on this, both finding the inverse and having you graph some stuff and saying whether it's 1-to-1. We'll pick up here tomorrow.